Good evening, friend. So today we are going to start the topic discussion pure rolling motion on inclined plane. So if you see here, we are taking a case of pure rolling motion, but we are taking not a flat plane, we are taking inclined plane because it will contain the multiple concept. So we will discuss here. So first thing, if you see here, we have given here inclined wedge of height h and angle of inclination given theta, and we are taking a circular body for performing the rolling motion. So we are taking here circular body, and if you see, the circular body can be anything like a ring, disc, solid sphere, hollow sphere. So we are taking a general case of circular body, and we want to calculate here what will be the time taken to reach the bottom point. What will be the time taken? Second thing, we want to calculate here what will be the center of mass velocity when it will reach the bottom point. And third thing, we want to calculate here what will be the acceleration here. And fourth parameter, we want to calculate for performing the pure circular motion, for performing the pure rolling motion, what will be the minimum friction coefficient. So these four parameters we want to calculate here. So first we start with the calculation of friction, minimum friction coefficient. For calculation of the minimum friction coefficient, first we will apply the all acting forces here. So if you see, first acting force is gravity, which is mg force. Second, if you see, normal force, which is passing through the center of mass. And third, we want to calculate the friction direction. Friction have two options: either it can act upward direction, either it can act downward direction. But if you see here, the velocity of center of mass is downward, and because of downward velocity of center of mass and acceleration is downward, so here this body perform the rolling motion, circular motion will be omega clockwise direction. So in the clockwise direction, the rotation is performed about the center of mass. So that's why we want to calculate the friction direction. So how to calculate the friction of direction? We will apply here the friction force in clockwise direction. For applying the clockwise direction, we have to apply the friction in upward direction. So friction we are taking along the inclination in upward direction, which is F. Now what we want to calculate here? We want to calculate here the minimum friction coefficient. So for this we want to write the equation. So if you see, mg have two components. So first we will resolve here this along the inclination, which is mg sin theta, and perpendicular to the inclination, which is mg cos theta. Yes, so now we want to write the equation. So for force, the writing equation will be equal to mg sin theta downward. So we will write here acceleration direction. So mg sin theta minus F is equal to mass into acceleration. This is our first equation. Now we want to write the friction next equation. So friction next equation will come because of center of mass is performing the rotation motion. So this about this center of mass, this body is performing the rotation motion. So acting force, applying force, which is creating torque, is here normal force. Normal force is passing through the center of mass, it will not create any torque. Mg force is passing through center of mass, it will not create the torque. Only friction is passing away from the center of mass, which will create the torque, and this torque will be in a clockwise direction. So here we assume the clockwise direction, acceleration is alpha. So we will write the torque will be equal to Fr is equal to I alpha. Fr is equal to I alpha. Now we will write we know for performing the pure rolling motion, this point of contact is called the instantaneous point of contact, is in rest, and here the velocity of center of mass is equal to omega r. For performing the pure rolling motion, this formula should be applied here. So here instantaneous point of contact is in rest. So because velocity of center of mass is omega r, from here the acceleration formula is equal to A equal to alpha r. This two formula is very important in this derivation. So here we will put this alpha is equal to A by r. So we can write here I A by r. So from here we can write we can write here friction is equal to, sorry, what we want to do here, we want to put the acceleration value here. We want to put the acceleration value. So we will write the acceleration value here. So acceleration is equal to F r square divided by I. Yes, and now we will put this acceleration value in equation first. So if you put the value of acceleration, so we can write this value is equal to mg sine theta minus f m f r square, and in place of I we will take the general case of circular shape body, which is equal to mk square. So we will write here this value is mk square. M will be cancelled here. So from here we can take the friction force right side. So if you take the friction force right side, so we can write this value is equal to mg sine theta is equal to friction force 1 plus r square by k square. So from here we can write friction force will be equal to mg sine theta 1 plus r square by k square. So first important term we calculated, which is friction. Now we want to calculate what will be the minimum friction coefficient. So for this we need to bring the here limiting value. So we know in case of static friction, the limiting value of friction is equal to, friction should be less than either equal to n into mu. Yes, so if you see, we have given here F value and n value will be equal to mg cos theta. So we will put both value here. So if you write mg sin theta 1 by r square by k square, and right side we will take mg cos theta into mu. So mg will be cancelled here. So from here we can write the mu value should be greater than either equal to tan theta. So mu value should be equal to tan theta divided by 1 plus r square by k square. So this is the final value, which is minimum friction coefficient we required for performing the body in pure rolling motion. So here we want to calculate the first parameter which we calculated. So we will write mu should be equal to either greater than equal to 1 plus r square by k square. This is our first equation. First term we calculated. Second thing, we want to calculate the velocity. So for calculation of velocity we need to apply here conservation of energy. But before applying the conservation of energy, we need to check here, can we apply here conservation of energy, because friction force is acting here. And we all know friction force is non-conservative force, and once non-conservative force will act here, so how we can apply? But if you see here, friction force, because of friction force your instantaneous point of contact point is in rest. So this force is not performing any work done. So this friction is not performing any work done. So because of this we can say we can apply here conservation of energy and we can calculate the velocity easily. So we take a next slide for this. So we have given here inclined wedge of h height, inclination is given theta, and initially the circular body is in rest. Initially the initial velocity is 0. When it is reaching to the ground, it have two type of velocity. One is center of mass velocity and second is circular velocity omega, which is angular velocity, which is omega. Now what we want to calculate, we want to apply the conservation of energy. We know initial mechanical energy should be equal to final mechanical energy. Initially, because this object is at a height of h, so we can write the potential energy will be equal to mgh. And second, if you see here, we have given here initial velocity is 0, so we can write here the initial kinetic energy is 0. finally it will reach to the ground. That time the potential energy is 0, but kinetic energy we can write here, because of translation motion we can write the kinetic energy half m vcm square, and because of rotation motion we can write here kinetic energy is half I omega square. Yes, and now we want to convert this I in terms of m, and we want to convert this omega in terms of v. So we all know omega is equal to v by r. Omega is equal to v by r. So we will put this value here, v by r. So if you see here, left side we have given mgh, right side we have given half m vcm square plus half mk square and v square by r square. Yes, if you see left side m is given, right side m is given, so m will be cancelled. 2 is common, so we can write here, from here we can write the value is 2gh, so vcm square is common, so from here we can write 1 by k square by r square and 2gh. And if I want to write the velocity, so we will write the velocity here. We will write the velocity here. Velocity will be equal to under root 2gh 1 plus k square by r square. So we calculate the second important term. When the body reaches to the bottom point, what will be the center of mass velocity? So this velocity is equal to under root 2gh 1 plus k square by r square. Now we want to calculate here the acceleration and time taken. If you see here, we have given the acceleration, in this case this acceleration is constant, and if you see we have given the acceleration is constant, so in case of motion we can apply the kinematic equation. So we have given the kinematic equation v square is equal to u square 2as. So we assume the length of the inclination which is s. So from geometry we can write one relation which is s is equal to h sin theta. S is equal to h sin theta. If you see, v square will be equal to 2gh 1 plus k square by r square, but u square is equal to 0, and we want to calculate the acceleration. So acceleration we can write here, acceleration will be equal to v square by 2s. If you see, v square will be equal to under root 2gh, so I will write here under root 2gh 1 plus k square by r square and 2s. In place of s, what we will write? S will be equal to h sin theta. S will be equal to, sorry, here I write one thing wrong, so let me correct here. Yes, h will be equal to s sin theta. So s will be equal to h by sin theta. So from here we can write here h, and here we can write sin theta. So h will be cancelled here, and 2 will be cancelled here. So from here we can write acceleration is equal to g sin theta divided by 1 plus k square by r square. So third important term we calculated, what will be the acceleration for performing the rolling motion. Next we want to calculate what will be the time taken. So for time taken we will write the formula v equal to u plus at. If you see, for time taken, if we want to calculate, so we will apply the kinematic formula v is equal to u plus at. So u is initially given 0, so time will be equal to v by a. V is equal to under root 2gh 1 plus k square by r square. So I will write here under root 2gh 1 plus k square by r square. Second, if you see, acceleration we calculated g by sin theta, so I will write here g sin theta, and I will multiply 1 plus k square by r square. So this 1 plus k square by r square will be cancelled, root value and g value will be cancelled. So finally our time will be calculated here 1 by sin theta under root 2h by g 1 plus k square by r square. So we calculated our fourth important term, which is time. So time will be equal to 1 by sin theta under root 2h by g 1 plus k square by r square. So these four formula is very important. First we calculated minimum friction coefficient, second we calculated velocity of center of mass, third we calculated acceleration, fourth is calculated time. So mostly the question come from this parameter. So first we take the all formula separately in next slide, then we will take the problem. So if you see here, we are taking the next slide for the formula. So first we calculated minimum friction coefficient, which is mu is equal to tan theta 1 plus r square by k square. So this is our first formula. Second formula, we calculated the velocity of center of mass. So this velocity is equal to under root 2gh 1 plus k square by r square. Third formula we calculated the acceleration. So acceleration is equal to g sin theta 1 plus k square by r square. So this is our third formula. Fourth formula, we calculated the time. So time taken to reach the bottom point is equal to under root 2h by g 1 plus k square by r square, and sin theta we can divide by sin theta. So we will divide by sin theta. This is the fourth formula. So from this given four formula, we can calculate the all given values, all questions we can calculate. So assume we have given the question, but before this question we need to know about the k square by r square general values. What will be for the different body the value of k square by r square. So if you see here, we will take the body, second we will take here k square by r square value. So first body, if you see here, first body we take here ring. For ring we know k square by r square value is equal to 1. Second body we will take here disc. So disc we will take here the body which is half. The k square by r square value will be half. Third we will take here solid sphere. In case of solid sphere, this value is equal to 2 by 5. Yes. And third we will take here hollow sphere. So in case of hollow sphere, our value will be equal to 2 by 3. So this is the four important value which we need to know for calculation of all the values. If you see ring and disc, in case of ring you all know hollow cylinder will be behave as a, so I can write here in short, hollow cylinder will be behave as a ring, and solid cylinder will behave as a disc. So we are taking here hollow cylinder and solid cylinder case. So 6 body, if you see here 6 type of circular shape body we are assuming here, their value is given, which is k square by r square. So I take a question from the previous year. In IIT one question came, what will be the time taken, which body will reach which body will reach fast to the bottom point. Suppose we are taking inclined wedge body and we perform from the all body we are performing the pure rolling motion. Which one will be reaching here to the bottom point very fast? So for calculation of very fast, time taken should be less value. If you see here time taken formula we have given here t is equal to 1 by sin theta under root 2 h by g 1 plus k square by r square. So time is proportional to under root value of 1 plus k square by r. Rest value sin theta, h and g, everything is constant. Everything is constant for all the bodies. So only k square by r square will be determine our time taken. So if you see time taken will be less, the value of k square r square should be less. So which value will be less? So here 1 is given, this value will be 0.5, this value will be 0.4, this value will be nearly 0.6. So if you see, we are taking here the case of solid sphere, which is taken time is 0.4. So if you put this value 0.4 here, so this solid sphere will take the less time. So we can write from here, time taken by the ring will be the more time. So I will write time taken by the ring will be greater than the time taken by the, which body we should take? Hollow sphere. So we will write here hollow sphere. Then we will write here time taken by the solid sphere, which is, sorry, disk. Time taken by the disk will be equal to 0.5. So I will write here time taken by the disk. Then we will write it will be greater than the solid sphere. So time taken by the solid sphere. So this is the order of time taken. So from here we can write solid sphere will take the less time to reach the bottom point. Suppose they will ask about the what will be the acceleration for solid ring. Sorry, what will be the acceleration for ring? So acceleration for ring, if you see g sin theta 1 plus k square by r square. So acceleration of ring you will write easily from the formula. Acceleration of ring you will write easily from the formula g sin theta 1 plus k square by r square. So k square by r square for ring is equal to 1. So you will put this value 1. So this value will come here g sin theta by 2. So easily you will calculate this value. Suppose they will ask about the velocity of center of mass. Only you need to put the value of k square by r square and you can calculate the velocity of center of mass. Minimum friction coefficient you will take the reciprocal value of k square by r square. So in case of solid sphere you will write 5 by 2. In case of hollow sphere you will write 3 by 2. So you will take reciprocal value and you will put the value and you can calculate what will be the minimum friction coefficient. So if you see here, we calculated the minimum friction coefficient, velocity of center of mass, and what will be the acceleration, what will be the time taken, everything we calculate for pure rolling motion along the inclined wedge. So this is the whole concept. So thank you everyone for joining the class. We will meet you in the next class. So thank you very much. Yeah.